All right, let's go ahead and kick things off. So, thank you so much for everyone for tuning in today for our webinar on sensing technology with analog devices and aero electronics. I'm Brittany Nelson, Partnerships Manager at Indiegogo, and here with me today is Keaton Anderson, Engineering Manager at Aero. Analog Devices is the official semiconductor technology provider of the Aero certification program, enabling entrepreneurs to interpret the world around them with unmatched technologies that sense, measure, and connect. Quick note before we get started, if you have any questions, please use the Q&A button at the bottom and we will try our best to address them at the end. All right, without further ado, Keaton, why don't we go ahead and get started? Thanks so much for being here.
Thanks, Brittany. Hi, everyone. My name is Keaton Anderson. I am really excited and delighted that I get to do another webinar today. This is number 3 that we've done. We had one covering medical devices and smart agriculture. And today we're going to be going through sensors, which is just such a broad topic. So I'm probably going to dive right in because we got a lot to cover. But again, if there's any questions, definitely throw them down there. I'm really looking forward to kind of getting to go through all the different types that are available. So without further ado, there's a sensor for that. The things that we are going to cover today is an overview of sensors. So what type of things exist in the market? What are they commonly used for? And then we'll go into the best practices for developing with sensors. And so this is going to be kind of looking at it from more of a practical kind of form. From there, we're going to talk a little bit about analog devices and what makes them really the best in sensor technology and everything that they have to offer. And then we're going to also go through the Aero certification program and how that can potentially help you with your design. So we'll kind of go through a little bit of an overview of sensor technologies here. I felt like this was one that there's that new like Apple commercial that's come out that's been like, in the future, there will be all these things. And then they're like, oh, that already happened. And that's kind of the way that I feel like it looks with sensors right now is that there's a lot of technologies that exist that you may not be aware of or things that get repurposed in many ways. And that's kind of something that's been really interesting about sensor trends is that you've kind of seen where we've had a sensor that's kind of come out and it maybe ends up getting reused or refashioned in a different way, particularly things that may be more on the commercial side and then eventually come back into more of the retail or kind of consumer versions of them. So let's take a look at some of the sensors that are available in the market right now. This is my categorization in buckets. I recognize there's probably some overlap here, right? In that they're not always, so I'm going to talk about environmental first. Environmental could also include air quality, but I'll have a separate bucket about that. So this is just kind of my browsing and boxing of them, but you could definitely see that there's probably some overlap there. So environmental sensing is kind of looking at anything and everything associated with temperature, humidity, kind of what's going on from that front. And so when you think about environmental, this is going to be, I just kind of had done a smart ag webinar, and this is talking a little bit about how do we kind of continue to look at the conditions that exist around us. This has become really common in, if you look at your phone or something like that, you'll often get those sensor readings. Those are going to be data feeds that come back. But those are some of what, we're kind of looking at when it comes to environmental. Those, and I'll kind of touch a little bit briefly on how each of these works. One thing to kind of recognize with sensing technologies is that you'll have a couple of different very key elements that are going to show up, things like voltage, capacitors, resistors. Those are a lot of the basic building blocks. And so in this idea, with temperature sensing, you might be able to see where there's two metal plates and there's an element in between that'll determine a voltage based on what is the difference in temperature. And as it rises or falls, that voltage will change. And this is going to be kind of a common element that you'll end up seeing with different sensing. The next one we'll talk about is positioning. So this has to do with how a device is kind of, how it determines whether or not where it's being held. What does that look like? A great example of this is just going to be your phone, right? So when you go to pick up your phone has an accelerometer built into it that says, hey, I've been moved, wake up, determine that there's something there. Accelerometers and gyroscopes, as well as inertial measurement units or IMUs, those have become increasingly more common in all sorts of devices, right? So you're going to need accelerometers for, in particular, it really helps with that sleep power, right? So you can be able to turn a device off, you can kind of let it sit, and until I determine and detect that movement, I'm just going to kind of wait and stay in that sleep load. And that prolongs battery life. And it's been one of the reasons why you've seen that cell phones have been able to get longer and longer and longer over the years. The next bucket that I'm going to talk about is air quality and particle detection. This is really common in things like smoke detectors. Obviously, air quality can go even further. There are sensors that can determine gas mixtures and what's going on. In terms of being able to see what's the breakup, what does it look like, carbon dioxide, hydrogen, so on and so forth. Um, this is a really common way in that you're going to be able to. There'll be like two little plates, and they'll determine if there's a current kind of going through. If that's becoming blocked, then we can see, hey, there's something that's preventing that, and oftentimes that'll trigger off that kind of particle detection saying, hey, something's present there. The next thing is force and pressure. This one is somewhat self-explanatory, but you have both the force side of things where you're kind of pushing down on for one to determine like, hey, I'm trying to do a weight or something like that. Pressure, I tend to think of this a little bit more as either atmospheric pressure or like a tire pressure, something like that. They're a little bit different in terms of the way that they're created. The atmospheric pressure is going to create a little capacitor using the atmosphere as part of the element. And as it changes, it'll be able to change that kind of capacitance total. So they're similar in the way that they look, but again, I recognize those devices could be somewhat spread as well. The next one is going to be motion sensing. This is something that you'll commonly see in occupancy. And so when we're looking at that smart city, smart buildings, smart home aspect, being able to turn lights on and off, oftentimes what you'll have here is a motion sensor. And those are used through what's called a PIR or passive infrared, where it'll just kind of be waiting to see until it detects, hey, is there a change in heat? Am I able to see? There are some that work off of acoustics as well. So when someone walks in the room and it can hear thumping or something like that, those obviously have to be very, very fine measurements. But those are some of the elements that you end up seeing there is just that you'll have both that passive infrared or that acoustic as well. And that helps to be able to say, hey, if no one's in the room, go ahead and turn those lights off. And the moment they come back in, we'll flip them back on. The next one is proximity or time of flight. These are somewhat similar in that you're going to see, so a proximity sensor is kind of just saying, hey, does something exist, yes or no? And where it's going to get even better is when you can start to determine that range of how far away is that object from me. So a great example of this is things like Face ID, right? So when you pull it up and your phone's looking at your face, it has to be able to determine, how do I focus that lens? How far can I tell that object is away? So it's going to fire a little IR beam. When it comes back, it's going to say, hey, this is how far that object is. Go ahead and set the lens to be able to look in within that time frame. And that obviously has even further applications into things like automobiles, automated kind of driving, those kind of applications where you're going to see, I need to be able to kind of more precisely determine distance. And so those are becoming much more popular. And we'll talk about those a little bit more later. Um, the next thing is going to be optical. When I think of optical, I'm thinking of detection of light or color. This is starting to become, you can obviously do some of this in terms of with videos and whatnot, but being able to have more of like a photodiode that says, hey, when light is present, do certain things. Those are often a little bit more of a low power option. So with the optical sensing in this regard, that photodiode will change its electricity based on how much light is coming in. Acoustic, this is kind of the one that probably most people are familiar with. The sensing of this is going to be that kind of microphone element. So as sound waves are coming in, they're going to be vibrating kind of that diaphragm that will have the magnet, and it picks up the waves and creates essentially an electrical signal off of those frequencies. So that's how you're going to be able to look. This is obviously a super common way of doing it. You can see, I won't say it because my phone will react, but things like, hey, Google or something like that would be a way that you could start to see these audio triggers. And again, these elements and a lot of these sensors are going to have things like polling, where you're kind of waiting for a keyword or you're waiting for a trigger before you then take a next step. So that power that you're having to do is keeping the sensor on at very small intervals so that you're not having to do it constantly on. It's just looking, wakes up, sees if the keyword has been present, and then if not, it goes back to sleep. So that's one of the ways that you can kind of monitor battery control as well. And then the last one is liquid detection. There's a bunch of different ways that this is done. One of the ways, so for example, there's like those children's toys that if you throw in the pool, it'll cause it to like start swimming and kicking and singing and everything like that. In those cases, what you're looking at is you'll have two electrodes where you're trying to generate a current between the two. And liquid detection can be done very similarly in that regard. Is if you can actually create a signal between 2 points of open electrodes, then it'll close that circuit and it'll cause the current to flow. The other one that's really common here is if you look at things like, hey, how much gas is left in my tank in my car? Those use a Hall effect sensor where essentially there's a little float ball inside of the tank. As you fill it up, that rises, and then based on where it is positioning wise, you can tell how much fuel is in there. So a very practical application. This is just kind of the basic overview. There's a ton more that goes into just the sensor market, and new things are coming out every day. One thing that's particularly interesting is just seeing how these are being developed, and I'll talk a little bit more about that in the next section. So the next thing I'm going to cover is going to be those sensors best practices. So these are, I'm going to go through a little bit about just in general with sensing and IoT, sensing for your product, and then we'll talk a little bit about going overboard with sensing. So in terms of IoT, you're going to see that sensing is going to become more and more critical towards the development of new products going forward. And while a lot of people are going to want to talk about like, hey, in order to be able to get to IoT, we really need the 5G to be prevalent. We're really going to need to see different signals. And while that is absolutely true, I'm not trying to say that is not true, sensing is going to be one of the heart of how those networks actually deploy. So while it is important that, hey, I can connect my new device via Bluetooth and that can potentially talk to my phone or my computer or something like that, being able to get to those sensors to that low power area and really small and tiny is really going to drive that next wave of innovation of what you're going to see. So instead of right now, when I say, hey, Google, what's the temperature outside, it can go and talk to an API that has those temperature feeds, or it can connect to my own personal weather node if we have something like that, and determine. You'll start to be able to say things like, hey, where did I leave my pink sweater? And those are things where when you're deploying enough force sensors inside of say like carpet, or being able to do determination within sensors within paint. These are things that we haven't even really begun to scratch the surface of, that as you start to deploy more in that area, it's just going to vastly change the amount of data collection. And as you can imagine, the more devices that are out there, the more data that's going to be. So data privacy and security and everything become even more important, but sensing is really at the heart of driving that innovation. And you're starting to see us start to break into that a little bit. The next piece of this is, let's look at sensing for your project. So I had kind of alluded to this a little bit earlier, but sensing is going to change potentially the way that your customer engages with both their environment and with your product, right? So an example of this is if you go back 10, 15 years, we weren't really using audio cues as much to engage with my product. I mean, my dad just got his first Alexa and he just talks to it all day. That's all he does. But he would have never even thought to have done it. And so it changes the way that the consumer might have looked at how they would engage with the environment around them. And I think this is going to become even more critical just given where the world's at right now. So you're going to have a lot more that's going to require not being able to touch things, not being able to not having contact against different elements. And because of that, those sensors in terms of things like accelerometers to determine, hey, have I picked something up, or am I, being able to look at that way. Infrared obviously being a key element in that regard, being able to determine how far is something away, is there a hand up or something like that. You're going to see more and more of those come, and those are going to be driven very strongly by that sensing environment and by the ability for sensors to get both cheaper and more efficient. And then the last thing I want to talk to, and this is more of just a kind of personal, hey, I've seen these kind of pitfalls before, is going overboard. And what I mean by this is you can get a little bit, you talk about how there's like, sensor overload, where if you're in the middle of an environment where you're at a concert and there's lights flashing and everything going on, that like that's too much for your brain. And very similarly, when we start to think about sensors in respect to your processor or the microcontroller or FPGA or whatever on your unit, too many can start to become problematic. And I'm not saying that you can't do it, but what will happen is you're going to require lanes of communication to talk to each of those, right? And so if you have too much coming in at one time, if you don't have enough lanes to be able to talk to, you may not be able to get the data that you're looking for. And then every time you add more elements onto your device, what you're going to end up seeing is you have additional processing, you have additional power that could potentially lower efficiency. And especially as you're deploying things that are more in a mobile world, your battery efficiency is going to become super important. The consumer nowadays is demanding and really wanting to have battery life that is all day and potentially more days. I should be able to go out for a weekend and not charge my phone. Those are the things that you're going to start to see even more, is that lower power efficiency, being able to do that polling, being able to use elements to keep more things asleep is going to become even more critical in your design. So if I'm starting a new design and I'm potentially looking at a new product, I would work my way up. Start with an evaluation board for one sensor. Once you feel comfortable with that, add another. But you may not want to go completely overboard with deploying too many sensors at a time. All right. So let's talk a little bit about analog devices sensor highlights. And these guys are honestly like my favorite when it comes to getting to talk about sensors. Really, there's pretty much everything under the sun that you can highlight here. And I'm going to go into their particulars of their portfolio and some of my favorite things. But they really are a company that provides as much help as you need, being able to give you videos, being able to provide you things like wikis, quick start guides, evaluation boards. If you've never developed with a sensor before, I'd recommend you start here, because it's going to be both the most precise thing that you need, as well as probably one of the easier ones to get started. Speaking of precision, I want to do a little bit of a quick review. So I did highlight this in my medical series, but I'm going to do it again. So apologies if we've already gotten this lesson. So why is precision important? So let's pretend that we're looking at a temperature. We're trying to take a temperature range between 95 and 105 degrees Fahrenheit for this example. So 1 bit of precision means that you will have two options. So that means you can either have 95 degrees or 105 degrees. 2 bits of precision means that you're going to have four options. So in that first one where you have the 1 bit of precision, it's either a 0 or 1. Here it's 0, 0, 0, 1, 1, 0, or 1, 1. You have those finite amount of combinations. And those correlate to essentially degrees at, you take that 10 degrees, you divide it by 4, because that's the number of options, and there's the potential frequencies that you have. So, or excuse me, the potential temperatures that you have. So if I go to that next level, so let's go to 3 bits of precision, now I have 8 potential combinations. So this means that I have 95, 96.25, so on and so forth. And why this is important and why I'm kind of going through this is, you can see just in this small 10-degree temperature range that 2, maybe 3 of these are what we would consider to be healthy temperatures for humans, right? That if you go outside of that, now we're starting to look at potentially feverish conditions. But I really only have a small window there that I'm working with at that 3rd bit of precision, right? Let's pretend I'm going further, and let's say I have 16 bits of precision. So now I have 65,000 options of bit in terms of those temperature ranges. So instead of it being that 95, 96.25, now it's 95, 95.00015, so on and so forth. So there's a much wider range in there to be able to say, I actually know how close I am to the real temperature here. And this may seem silly at the 95 to 105 degrees, because those are such finite measurements, and that we really aren't super concerned if someone is 98.2 or 98.234, so on and so forth. But when you start to think of this in sort of those precise measurements as, hey, did my phone move a fraction of a millimeter? That's when those level of precision become really important. And that micrometers, microseconds, those things where we're starting to get down to those really, really tiny things that to the human mind are all just one period, but for a computer are very different stages. That's when it starts to become important. And that's one of the reasons why I like to feature some of the devices from Analog Devices, is that these guys have a ton of precision at not a ton of cost. You're not asking to kind of fork over the farm to be able to get there. You're going to have it where there's devices that you can work with at a reasonable range and still get the precision that you need. So let's take a look at the portfolio that we have offering wise here. So I talked a little bit about that position earlier. So those are going to be things like accelerometers. Accelerometers are going to be that XYZ axis. So being able to tell, hey, am I going up, down, left, right, so forth. The gyroscope is going to be your jaw, or so that you're able to see, yaw, excuse me. So you're able to see, am I tilting? Am I going this way instead of this kind of planar aspect? When you combine those, you get that IMU. So that's going to be that device that says, hey, I'm measuring on 9 degrees, and being able to see where in space in a sphere am I going? Have I tilted? Have I gone up? So on and so forth. You may not always need a combination of them. In many circumstances, an accelerometer is acceptable for a lot of what you're trying to do. For example, on the phone, you may not need to necessarily say, where am I at in space, so much as it just, did it move? That being said, on the flip side of it, you're starting to see more and more software like the measure tool on phones where you're being able to determine the distance and you're getting those more fine movements in terms of that three-dimensional space. So you are seeing that they're deploying more and more of those type of IMU elements. The next one that we're going to look at here is this environmental. So I had done a whole webinar on smart ag, right, where I had talked a little bit about this. So I won't harp on this too much, but this goes into things like water quality, pH measurement, temperature. All of those are going to be useful elements. And if your device is being planned on being deployed outdoors in any method, you're definitely going to want to look at this. One thing that you have to keep in mind with consumers is you never know where they're going to try to take something. So you may think, hey, I've designed a really cool Bluetooth speaker, and then they'll try to take it into the hot tub or into the middle of the mountains and go skiing with it. And you don't know what that temperature range is. So having those temperature sensors potentially built in or a water detection sensor built in enables you to start to try to ruggedize the device. So if I see, hey, it's too cold, shut some things off. Give a user a note saying, hey, it's a little too cold. Or if I see that water coming in, shut the device off. Try to prevent things from going and short circuiting. And we'll talk a little bit, but they're trying to start to ruggedize things a bit more. But even then, knowing what conditions your device is being deployed in potentially becomes really useful in terms of protecting it and making sure that it can last in those more harsh environments. The next piece is this optical one. So I kind of put the medical ECG in here as well. You're starting to see, as particularly on devices like the watches and whatnot, they'll be able to do things like determine, are you hydrated enough? What's your blood oxygen level? A lot of those are going to be using sensors where they're going to be just deploying right on skin level and kind of coming back. But I did want to call it out because Analog Devices has a really unique solution for medical ECG and EKG. And I actually talked a little bit about this back in the medical webinar, so I won't go too much into that. I'll go a little bit deeper into the time of flight sensor here, which is actually super interesting. And there's a lot of applications that you're going to see that become even more relevant as time goes on. And then the last one that I want to highlight in that industrial section is that smoke detector one. So you're going to see that this is an area where, as we're seeing more and more of new materials being deployed that are potentially highly flammable, it's becoming even more critical to be able to see and detect smoke early in a fire to be able to try to do both from a health and safety and then from a loss perspective. And so there's a really cool solution that they have developed that I'm going to touch on briefly as well. So let me go ahead and jump into my first kind of deep dive here, which is an accelerometer. So this is looking at the ADXL 343. This is going to have, you can choose that range between that 10 to 13-bit resolution like I was talking about earlier. So that resolution is both important, and then it'll communicate over SPI and I2C, just like I had talked about before. And these have built-in motion detection features like that tap and double tap, which is useful. So if you wanted to be able to offer your consumers a way to engage with your device, but you don't want to have a ton of buttons on there or something like that, adding a tap or double tap is actually a really unique way to engage with your device. So instead of it being, hey, I have to push 4 buttons to try to get a certain sequence to go, I can do double tap and then talk, right? And those are ways that now I'm not necessarily having to go in and learn a sequence of button presses, but now I'm trying to let my users engage with it from a tapping perspective. And this is driving things like smart rings and such, where you can be able to tell things like that, both low power and being able to be pretty small. And you can kind of adjust those thresholds with this. And this is a device that it's actually pretty reasonable. These are, a couple dollars that you're going to be able to do it, especially at volume. You could look at quite a few of these. So this is an area that, again, you have that precision without driving that cost too much. The next one we'll look at is this water quality boards, right? So if you look here on top of this, let's see if I can annotate on it. You're going to see, so right here on top, these are going to be your water sensor boards. Those are that CN0428. And then under here, you're going to have both an Arduino sensor board, that Arduino Shield board style, as well as that microcontroller that you can do that will take those measurements. So this is a way that you can be able to get it. I'll highlight this a little bit later, but a lot of these resources are available online that you can just go to. Both arrow.com will have videos, as well as analog.com will have a lot of additional content. So really some interesting stuff to be able to look at here. And again, one of the things that I do like about Analog Devices is you have that shield board format. So instead of it having to be where you're completely developing from scratch up, you could actually start with something that's in a form factor that you may have used before. The next one that I'm going to touch on a little bit here is this time of flight sensor. I'll actually show you, there's a really good video around this as well, but this is going to be how you're looking at things like that facial recognition, that Face ID being able to determine and look how far something is away. And this is something that very honestly is going to become super critical in the next couple of weeks to months with different devices, as you're just going to start to see that there's going to be more things that say, hey, I'm not comfortable with being able to have someone touching the device. I need to determine how far that person is away. And so you can be able to see there that you have those near ranges between 25 to 80 centimeters, all the way that far range of 3 meters to 6 meters, right? And you can have that 2% within 2% accuracy on all of those. And so you can start to be able to better determine, hey, is someone standing farther away? Is someone standing closer? And I think you're going to see that this is an area that's going to really take off even more than it has right now. Obviously, you see these deployed in the phones as well as in automobiles and such. But this is, I think, a big one. So keep this in mind as a time of flight sensor. I think it's going to be really useful over the next coming months and years. And then the smoke detection, I really wanted to touch on this one because this is a circumstance where ADI has developed really the entire solution from start to finish, and lets you kind of layer based on what you need. So what you're seeing there is that ADI cup 3029 board, which is that microcontroller combined with that CN 537, and those are going to be that reference design for smoke detection. So inside of that design there, when particles come in, you're going to be able to detect and say, hey, I'm no longer able to see the electric path coming through here. Throw a flag, trigger the device to start, putting off the alarm because there's smoke. But what's additional on top of that, so that's just the hardware layer of it, is they also have the option to get both the internal embedded software as well as the data done for that testing for that UL 2017. And those are ways that you could now look at a device that, I mean, truthfully, you could almost go to market with this and being able to have it where you have both a reference design and a development board. And additionally, you have the code deployed on there of, hey, I know different layers. And that data set includes things like, hey, what's the difference between an oil fire, smoke fire, cloth, all sorts of different things that are kind of coming in there. So really just, again, I can't say enough nice things about the levels at which analog devices has gone to think about how we might deploy it. So again, if you're looking at sensing, it's a good place to start. And one last thing on that point is there are additional resources that have been provided. I'll talk a little bit about the certification program here in just a moment. The other piece here is that there are a ton of videos and content that we've published around things like this. So if you look at, we have a light sensing technology, that's a screenshot from arrow.com. You got those innovative current sensing solutions. Those are awesome, cool cars that you're able to then determine, are those batteries charged enough, doing that kind of aspect of it. That's on arrow.com. Vibration sensing technology, and then that time of flight. And again, all these videos are on arrow.com. You can also find them on YouTube, but definitely go there to the articles and videos section and check them out. This is some really, I think, cool stuff, and that you have, these little pieces of content that are 2 to 3 minutes long that might give you some really interesting information, and then you can dive deeper in there with that article to say, hey, let's take a look at the components associated with that, and let's go deeper, let's go further with it. So I wanted to leave this up for at least 30 seconds while I was talking, so you could jot this down or screenshot it if need be. But if not, go search sensing and analog devices, and you're going to come up with something. It's always going to be good. So with that, I am going to move into the Aero certification program. So all this information that I've kind of gone through has been a lot of me just, I've done research over time. I was an FA in the field. Sometimes it's nice to have someone that you can say, hey, I'd like to throw some questions off of regarding sensing. And that's essentially why this program was built, was to be able to help entrepreneurs and innovators like the people on this call, and kind of help them move their project from just that idea stage all the way through production. And so the program's really built on this platform that you can bring ideas, you can bring questions to Arrow, and essentially we'll help work with you on your prototype to offer you a suggestion. So an example of this might be that, hey, I have a new device. We've seen a couple different things from like, a golf ball that I want to be able to track. Well, so you could put an accelerometer in there and be able to determine, how hard that was being hit. We've seen, a firefighting system that was deployed that required sensing to be able to determine where people are at. Are they standing upright? Are they, down? What does that look like? And so we've really seen a lot of different things that when it comes to this market. So you may not necessarily know what you want to start with, but I can guarantee you that we can definitely at least open that conversation with you and start brainstorming on what's that next piece going to be. From there, we'll help you with being able to kind of point you in the right direction for those prototyping pieces all the way through your kind of product launch. And we really want to see that you have success. Really, the way that we're going to have success is if you're having success. We are going to be there as your partner. And then at the end of the day, we hope that you choose use us as your distributor for components, and we want to be a part of that. And that doesn't just stop at that first production or at that first pass through manufacturing. That's going to continue on to additional product iterations and even through end of life. And what we've seen here is that people who have applied to the program have raised 87% more funds on the platform and are 4 times more likely to reach their goal. This is something, honestly, the program is something we're really proud of. We've been really excited. We've been partnered here for about 4 years now, and I'm honestly delighted to get to come and do these because this is the fun part of my job when I get to go home for Thanksgiving and talk about like, guess what I got to work on. Like those are some of the fun things that I get to do. So I'm really excited to continue to kind of work with this. The other benefits that you're going to be able to look at here. So if your device does come to us and we kind of review it and say, hey, this looks like it's ready to go to manufacturing right now. We feel like you've gotten all the technology in there that you need. You can get that Aero certified technology badge. And what that's going to look like is on your page on Indiegogo, you're actually going to get a little badge that says, hey, this has been reviewed by Aero engineers. They've had a chance to look at it, and essentially that we've been able to work with you on your product. You're going to be able to get both engineering and manufacturing consultations. So if you say, hey, I've actually got a product that's pretty close, I'd just like someone to talk to about how do I get this built? Who might I want to talk to? That's another area to go. And then there's the additional pieces of both that $1,000 up to $1,000 off components on arrow.com, as well as those extra social media features. So again, I highly recommend if you have something that you're building, if you're getting ready to deploy, we have the link right down there to join the program. We'd love to get a chance to work with every single one of these new ideas, and I really appreciate everyone's time. So with that, I am going to pass it to Q&A, and Brittany, I'll hand it back to you.
Awesome. Thank you, Keaton, so much. That was super informative. All right, we do have a couple of questions here, and we had a couple of questions submitted before the event as well. So I'll go ahead and run through those.
Let's do it.
All right, so this one's a little bit specific, so we can maybe just talk generally about the topic, but will sensor technology be stable enough to run an interactive live music performance using audience mobile phone sensor data? So maybe just kind of speak broadly more about like sensor stability.
Yeah, definitely. So two aspects there. So let's talk about sensor stability. Sensor stability is something that has greatly improved, and what you got to think about, especially when you're looking at like that mobile phone environment, is think about. So you talk about devices that are deployed in the home. You can roughly guess around what the temperature conditions are going to be. Maybe you have a very cold day, or you have a very hot day, or if you're in Phoenix and then your mailbox is melting, a very very hot day. But for the most part, you can kind of know those ranges. The difference with a mobile phone is you may not know where that's going to go. They could be on a ship, they could be in the mountains, they could be out bike riding in a bunch of dirt. So those sensors have to be a little bit more ruggedized, and that encasing has to be more ruggedized. So from a stability perspective, those are going to be again probably going to be some of your more stable devices. In regards to say like a concert environment and using like, let's bring all that mobile phone data in. One thing that you're going to want to consider there is where the user's deploying their devices. So if they're aware of the fact that this is happening, they may be able to raise their phones up, and that's going to collect better data. If it's in their pocket, again, you're going to have a little bit more of a muffled, the speaker may be covered, something like that. So when you're thinking about those type of solutions, what I would recommend is just think about how your user's going to engage with it. Obviously, microphones anyone can attest to the fact that there's times that Siri's gone off while it's in your pocket, right? So the fact is they can definitely pick up that level, but I would just want to recommend that you definitely offer to your users, whoever's going to be using this, that kind of where is the parameters, where would I like you to try to operate before you go into the more specific use cases.
Got it. Got it. Okay. Next question is kind of similar. It's more about like waterproof sensors. Can you
Mhm.
touch a little bit on how waterproofing works?
Yeah, so there's different levels of waterproofing, and they're rated on what's called it's an IP scale. There's two different sets of it. There's going to be ones that are just specific for dry environments, looking at things like dust, and then there's the other half of it, which is going to be things like waterproofing, and those will go up multiple levels from things like, hey, it got someone sneezed on it, to hey, I've decided to put this underwater in a pool for a couple of hours, kind of thing. And so there's a varying degrees of IP ratings based on those levels of waterproofing. And you'll have to actually do testing for your device to prove like, hey, it worked in a submerged environment for 1 meter for expiration. When it comes to the sensing elements, what you're going to see is that in many circumstances, these are going to operate off of those capacitive, resistive, and voltage based ideas before, right? So I made that comment earlier to things like, how would I be able to determine a water detection? In that case, the circuit's mostly open, and then I just use the water as a conduit to be able to determine, did I actually make a connection? And something that's rather interesting thing about that is, if you were to take one of those toys and put your finger on it, it'll go off and think, because that connection is actually made through your finger. So when you're looking at like waterproofing around devices, what will happen is they may operate within their conditions, but just in a more sealed enclosure, and be able to still get that information. One thing that would be a challenge, for example, though, is if I was trying to do, say, like an atmospheric pressure check on something and I've put it underwater, obviously the difference there is going to be significant in terms of the pressure is now different, right? But a temperature sensor might still function okay, because you have that kind of layer where you're able to tell, has the resistance, has the electricity changed between those two objects. So it may still operate within still that sealed environment, but obviously that sealed environment may be slightly different of a temperature perspective than your more open area. So when you're thinking about the waterproofing elements, they're going to end up sealing the device in many ways, and the sensor may operate still, depending on just if it's being able to be exposed to the external environment or not. Um, Sorry, just one more example there, like an accelerometer will still probably function just fine, because it's still looking for that movement in determination. So I think it's important that in the particulars there, you look at the type of sensor, but in most circumstances, they're somewhat independent, and that the waterproofing comes for the device, and that the sensor will operate as long as it's kind of been protected.
Got it. Yeah, so many things to think about. All right, next question here is I've seen pictures of government air quality sensors and they're huge. Do they have to be this big to be able to collect an adequate sample size for testing? So maybe a little bit more general on like the size that's required for these different types of sensors.
Yeah, definitely. That's a great question. When you look at the size of sensors, what you're often going to see is a trade-off here, right? So the precision and the accuracy that you're going to be able to get is also going to be based on the size of the device. So, for example, I could build a super huge accelerometer that was super precise, that may go into something like a rocket ship. That would be important. But my cell phone may not need that same level of precision. So when you're thinking about this, if you're seeing these large deployments, I can't guarantee that they need that, but I will say that in many circumstances, what you're doing there is you're seeing that trade-off where I don't need to worry as much about power, or I don't need to worry as much about size. And that is true of actually a lot of devices, not just sensors, that as I let things get a little bit bigger, I can pack more of a punch in there. And then over time, I can start to try to shrink those form factors a little bit. So don't go running around. There may not be red flags. It may just be based on accuracy as to why they're so big.
Got it. Got it. And then, kind of around those lines, like, is there a limit to how many sensors you can add to a device? Like, what's kind of the thought process and approach to how many sensors you want to include?
So the limit is really going to be based on your power requirements and those lanes of communication that I've talked about. Why it's important to be able to have open lanes of communication is, if you start to have, like, say, two sensors on the same lane of communication, and you have both of them fire off at the same time, you're going to have collisions in the data where you're not getting accurate data anymore. So you may be able to bundle them based on if you have a way of being able to turn them off and on and only let them communicate at certain times, but those lanes are going to end up driving essentially the limiting factor of how many sensors you're able to put in there. So when you're thinking about how many sensors to deploy in your device, one thing that I would recommend is kind of looking along the lines of, what's that MVP, what's that product that I really need to be able to, um, what are the things that I need to be able to capture first? Start there, right? So if I have a device that has to make sure that it's staying thermally cool, start with a temperature sensor. If I have a device that I need to know, has this been jostled or shocked or something like that, start with an accelerometer and build out from there. You will be able to add more microcontrollers, more brain devices to there that are looking for those pieces, and then go back and have like a central processing unit that's looking for all of it. So you could build something that has just like a ton, an unlimited amount of sensors almost, but it's going to then be super high power because you're not only controlling just one microcontroller, now you're looking at multiple in a device. And you'll often see that where you'll have potentially multiple processing units on the same board if they're doing higher levels of functions. Even like phones will have that as well. So again, it's not necessarily a limit. You could probably go as wide as you could think, but your device will be harder to regulate from a power perspective, and you will need to add more layers of processing as you put more on there.
Got it. A lot of different trade-offs to think about.
Yep.
All right. Here's a question. Have we seen any progress on the olfactory sensing front?
Interesting. I that is actually a good question. I'm not aware of anything that's better. I mean, obviously, so some of the challenges that you're going to run into with the olfactory is that, from a human perspective, you're going to have it where the smell will come in. Your brain's going to have to then determine what does that look like. There are a lot of devices that are out there that will use sense in a way. I think we actually had one come through the program that was an alarm clock that triggered by smell. And so in that circumstance, you could already have something where the scent is determined. But in terms of exactly being able to say, "Hey, I know exactly what that scent is," I don't think there's much out there. That'd be a more particular question that I could sit down though and have a discussion around. I'd have to do some research on it, but that's definitely a very interesting area that I think. Hey, as soon as someone comes up with it, that I'm gonna have a cheeseburger sensor on my phone that knows as soon as there's one available for me.
I'm picturing like a Shazam for smells. That'd be
That's
kind of
exactly what I
fun.
need. Yeah.
Okay, let's see here. There's a couple of questions in the Q&A that are pretty specific. So I recommend if you're looking for a specific type of sensor or something, definitely join the Aero certification program and have that one-on-one consultation with an expert. They'll be able to help you out. I think one more question here that I had was like how just in general, like how have you seen like the sensing technology evolve over the past few years and like where do you think we're headed next? Like are you excited about any category in particular right now?
Yeah, I definitely. So what you're seeing in sensor trends is going to be kind of very similar to technology trends in general, right? So you're going to have it where it's this: how can I get it smaller? How can I get it cheaper? How can I get it more compact, less power, that kind of thing? And what is really interesting to me, at least, is that I think what you're starting to see is sensors that may have been used in more of those commercial applications, things that are going to be more of those large scale, as they're able to make that technology smaller. A lot of these sensors are they're called MEMS, or electromechanical systems. And MEMS sensing has made it where you can make large sensor technology into more of a small form factor, to be able to determine. And so I think what you're seeing from a trends perspective is as sensors are being able to become more commercialized, you're starting to see them more in more consumerized. You're starting to see them more in these applications where you may have not traditionally seen that technology available before. And I think that that's really sparking a lot of innovation into things like Face ID being something that's kind of come out there, but things like the fingerprint sensors and stuff like that, those are becoming obviously more readily available, and that kind of changes the dynamic in terms of how does my consumer engage. So the second portion of that trend that I would then comment on is kind of, I had alluded to this earlier, but you're kind of seeing this where I have these sensing technologies, right, that are now becoming more available for consumers, and that's driving new ways that we engage with our products. And I think that that is going to be the other trend that you're going to see. I don't know if I could necessarily sit here and predict all of what you're going to imagine, but I will say that what you've kind of seen with technology is that the things that are driving those possible, what's going to be possible, what's going to be next, is those kind of things that may have seemed very science fiction before, things that may have not seemed real. Um, and you're going to see it where I think as the consumer demands more of it, we're going to try to push into that. So a lot of this 3D touch, this haptic feedback, is going to be something that I think is going to be coming up here in the future, where instead of having a physical knob to turn for a door, it may be something where I can feel the knob in my hand and I can turn it, and the determination of where my hand is from that infrared technology and that that kind of looking at the position will then cause elements to happen because of it. So I think something you're going to see there is this haptic feedback for being able to do a combination of both haptic feedback for the consumer as well as then sensing and positioning there for the device. And I think that becomes even increasingly more critical as it's going to be kind of very important to keep things very sanitized and make it so that users aren't necessarily touching things. So I expect that you'll see that even probably very coming very soon within things like sports environments where you might have a fan experience that you're going to want to engage, but you don't have multiple people touching and cleaning between. So I definitely expect that that's going to be where it's going very soon.
Awesome. Awesome. Well, thank you so much, Keaton. That was super helpful. There's a couple questions here, just kind of logistics. We will be sending a recording of this webinar out to all of the attendees. So you will have that in your inbox very soon. Also on just quick note on the Aero certification program, they are happy to sign an NDA. So there is confidentiality working with them. I recommend joining the Aero certification program if you have any more questions. It's totally free, and you can have gain access to an engineering review with an expert at Aero, just like Keaton. So if you want to join, just visit our landing page, enterprise.indiegogo.com/Aero. Just fill out the quick form, and someone from Aero will be in touch. All right. Well, thank you so much for everything today, Keaton, hosting and answering all of our questions. And thank you, everyone, for attending our webinar today. We will see you guys next time.
Bye, everyone.